jet streams? Please take the definition. Jet streams are strong, narrow currents, comma, concentrated in the upper part of troposphere, concentrated in the upper parts of troposphere, and it will move from west to east. Okay, irrespective of the latitude we are present. Generally, jet streams, we will talk about the characteristics anyway. Generally, they are present between 20 to 90 degree latitudes. Wherever they are present, they will be blowing with a higher speeds, like a narrow current. It means length of the jet streams, if you see length, hundreds of kilometers all around the earth they will be blowing. If you look into the width, it will be few kilometers itself. So they are narrow currents, like streams of winds which are blowing at upper part of troposphere. When they are not near the surface, like any planetary winds, they will be under the influence of Coriolis force, frictional force, pressure gradient force, everything. So they are out of all these influences, so they move with a faster pace. Okay, so that is a jet stream in normal. And secondly, as they are moving at a higher speed without any influence of the other forces, Coriolis effect, etc., etc., they move like the direction of the Earth's rotation itself, that is from west to east. Getting it? Now, please write the characteristics of jet streams. Characteristics of jet streams. Okay, first one, the circulation of jet streams is from west to east. The circulation of jet streams is from west to east. Okay, they circulate at a height of 7 to 14 kilometers. They circulate at a height of 7 to 14 kilometers. Okay, at times it will reach till 20 kilometers as well. Sorry, I mean it might cross beyond, it cannot cross beyond tropopause anyway. So sometimes the speed will increase, the speed is more than 20 kilometers per hour, 18 kilometers per hour or so. Okay, the height is 7 to 14 kilometers. Are you getting it? Okay. So jet streams moves with a higher speed. They circulate with a higher speed, around 18 kilometers or 20 kilometers per hour. Okay. Then please write on an average, jet streams are thousands of kilometers in length. On an average, a jet stream is thousands of kilometers in length and few hundreds of kilometers in width. Then around 2 to 5 kilometers of depth, like a band. Okay, 2 to 4 kilometers of or 5 kilometers of depth. Okay. Then jet streams are present between 20 degree latitude, that means 20 degree north or south, to poles. Between 20 degree latitude to poles. How many points you have written with respect to characteristics? 4. Then please write, there will be a seasonal change. There will be a seasonal change in the wind velocity of jet streams. There will be a seasonal change in the wind velocity of jet streams. Jet streams move faster in winter. Jet streams move faster in winter. Jet streams move faster in winter and slower, relatively slower during summer. Relatively slower. Relatively slow means compared to winters it will be little slower. That doesn't mean they will move with a slower pace. Okay. Then under that please write, jet streams are not always straight. Jet streams are not always straight. They will meander over a period of time. Jet streams are not always straight. They will meander over a period of time to form Rossby waves. Okay, it means most of the time jet streams move like this, sometimes they will move like this as well. Okay, I'll tell you how this happened. For example, there was a cooler air mass, okay, and a warmer air mass below. Jet stream will be tending to move like this. If there is a cooler air mass like this and a warmer air mass like this, okay, cool air mass and warm air mass like this, you will find jet stream moving in a meandering fashion. What is a air mass? Frontogenesis is another topic, okay. But as of now, just remember, jet streams doesn't only move in straight lines, they actually moved in a curved fashion as well, okay, to form Rossby waves. Getting it? Now, please write types of jet streams. Types of jet streams. Between 45 degree north or south to 60 degree north or south, between 45 degree north or south to 60 degree north or south, we observe polar front jet streams. We observe polar front jet stream. Okay, so generally jet streams will blow when there is a strong air mass above and below it. Okay, so if you consider the region there between 45 to 60 degree, below it we have a warm temperate region, above it you will have extremely low polar region. So there are chances of having a cooler air mass and warmer air mass, making that wind, the narrow wind, to blow in a certain way at a certain height. And coming to air mass, air masses are huge, body of air expanding from earth surface to tropopause. Earth surface nunchi tropopause varaku they will be expanding, and they will be having some hundreds of kilometers length. Air mass. Okay, we'll talk about that air mass. So when air masses were forming, generally air masses forms near temperate regions itself, because there itself you can have an extremely cold or extremely warm condition from below. Okay, near equator extremely high, near poles low temperature only. So in the temperate zone itself there are chances of having air masses. Are you getting it? Okay, near equator all over you will have only warm air mass. So you cannot specifically say that there is a air mass here, because all over you will have high temperature. But air mass is like a body of air, on an average it will have equal temperature. Okay, horizontally and vertically it will have. Horizontally, if you see, what actually an air mass is that, if you consider this earth surface, this is how our air mass looks like. Horizontally if you see, it will be almost having a similar temperature. So horizontally all over, but vertically if you go, it will have normal lapse rate itself. Okay, it means with increasing height the temperature increases, but in general if it is warmer we call it as warmer air mass, if it is cooler we have cooler air mass. Only two kinds of air masses will have. Okay, so near 45 degree to 60 degree we have polar front jet stream. Okay, please take a note. No, actually a cooler air mass requires much lower temperature. So it can form only, it can come from the polar region itself. Okay, but equator you have, so that warmer air mass itself will move over there. Okay, andukani in temperate zones generally you will find air masses. In tropical and in polar regions completely hotter or completely cooler. Okay, so that's the thing. Now please write front jet stream. Okay. When warm and cool air mass converges, we observe a subpolar low pressure. Between polar cell and feral cell. See people, the thing here is that whenever there are two air masses coming, we'll talk about that in detail anyway. For example, if I have a cooler air mass and a warmer air mass. Okay. So when warmer air mass enters into the territory of cooler air mass, matlab the cooler air mass is stable. Okay. Air mass generally have the conditions of the land in which it is forming. Okay. So if there is an air mass formed near the low temperature regions, the air mass will be cooler. So air mass will have similar characteristics like the region in which it is forming. So you have a low temperature region, say for example the 45-degree latitude and above itself. Okay. So there the temperature will be comparatively cooler and there are chances of cooler air mass. So cooler air mass means will be denser, it will be stable like that. It will not move. When warm air mass enters the territory of cooler air mass, okay, it means there is a movement of warm air mass itself. Warm air mass, which is actually low density compared to cooler air mass, it will rise. Okay, warmer air mass. So whenever like if warmer air mass comes into territory, warm air mass will rise. Even if cooler air mass comes into warm territory, then also warm air mass will rise. The reason behind it is warmer air mass is lighter. Agreed? Okay. So that's what is the reason you will find generally in those latitudes warmer air mass coming from the warm temperate region rising. Okay. Whenever air rises, okay, rises, it means it is converging in a rising phenomena will happen over there. Okay, air is coming from here and it is rising over there. Are you getting it? So during that convergence process, you actually observe a low pressure being created over there. That's the reason near poles, one reason what you know is that near the poles you observe the feral cell, between feral and polar cell, the air converging and rising. There is an atmospheric circulation in such a way. So when air is converging towards that area, the warm air mass enters into the territory, creating more chances of having a low pressure. You're getting it? Did you remember the subpolar low pressure? Low pressure ante enti? Air converge ayi rise avutundi. From where the air converges? One branch of air coming from the pole region, another branch coming from the tropical part. Both will converge and rise. During that process, warm air mass will accumulate and will enter into the cool territories and all. Are you getting it? So that's the reason we generally have a low pressure belt near the pole region. Are you getting it? Generally, what you imagine is that whenever there is low pressure in atmosphere, temperature is more near the surface. No. Are you getting it? Here, the low pressure is because of the convergence and rise phenomena within the atmospheric circulation and also warm air mass which is rising above the cooler air mass because of the density variation. And even it's a subpolar region, we'll find a low pressure over there. So there are many, reasons for having low pressure situation over there. Are you getting it? So if such phenomena happens over a period of time, you will find a low pressure belt being formed. Getting it? So you have a subpolar low pressure belt here. Within that subpolar low pressure belt itself, you will have this polar front jet stream blowing. Okay? Clear everyone? అందుకే whenever high temperature on land, it will lead to low pressure in atmosphere, but it doesn't mean that low pressure in atmosphere leads to high temperature on land. Whenever there is high temperature on land, we learn that it will lead to low pressure in atmosphere. Agreed? This is only a one-way thing. Whenever there is low pressure, it cannot lead to high temperature. That is a very important statement, because atmospheric variation will not impact Earth. If there is something need to be changed on Earth, it should be from sun, because Earth absorbs 51% of solar radiation. And it's the only energy source, because atmosphere cannot radiate. Agreed? When it radiates, it's not like an object, it's a gases all over. It will just radiate back to the atmosphere. Are you getting it? So only Earth can radiate or sun can radiate. Solar radiation, terrestrial radiation. Okay? So low pressure atmosphere will not create any high temperature on land. So that's the reason we have a low pressure near subpolar belt. And in that belt itself, we have polar, what is this? The polar front jet stream blowing over there. Clear everyone? Now, please take the note. Subtropical westerly jet streams. Subtropical westerly jet streams. Between 25 degree to 35 degree, between 25 degree to 35 degrees in northern and southern hemispheres, between 25 to 35 degrees, that is horse latitudes, between Ferrol cell and Hadley cell, between Ferrol cell and Hadley cell, we observe subtropical westerly jet streams. Okay, so here we have subtropical westerly jet streams. Then write tropical easterly jet streams. Tropical easterly jet streams. During summer season, tropical easterly jet stream, during summer season, tropical easterly jet stream move from Bay of Bengal to India. Bay of Bengal to India. Bay of Bengal to India, providing rainfall to the eastern coast of India. So it means sometimes there are certain jet streams which will actually tend to move from east to west, like tropical easterly jet streams will also be there. Okay, range matlab tropical easterly jet streams. So within the tropical regions itself, that means below your Tropic of Cancer itself, you observe tropical easterly jet streams. In the summer season, we actually observe different changes happening. Okay, but generally jet streams, because they are of higher heights, they must move from west to east itself. But in the tropical region, we observe some jet streams moving in reverse fashion as well. Agreed? So we have no reason for it, because they are at a higher height, they are out of influence, sometimes they will move in reverse manner as well. Clear everyone? Now, please write role of jet streams in Indian monsoon. Role of jet streams in Indian monsoon. Okay, so if Indian monsoon is asked, Tibetan low pressure, Mascarene high pressure, now whatever you are writing, this should be continued. Okay, please write role of jet streams in Indian monsoon. The subtropical westerly jet streams. subtropical westerly jet streams. We'll talk little detail about jet streams as well later, but now the content is regarding Indian monsoon, so we'll talk about that. Okay, subtropical westerly jet streams. Under that, initially subtropical westerly jet streams will present over Gangetic plain. Okay, during this Gangetic plain does not receive any rainfall. Okay, because jet streams will not allow a good convection cycle. It will not create clouds, it will not allow clouds to create and all, because it is like a faster wind which is blowing at the top part of the troposphere. When subtropical westerly jet streams blowing in the Gangetic plain, so it is near between 25 to 35 itself. So when they are blowing, it will not allow convection or any rainfall happening over there. So that's the reason Gangetic plain doesn't receive rainfall. Okay, now please write. As ITCZ shifts, the subtropical westerly jet stream will also shift. When ITCZ shifts, subtropical westerly jet stream will also shift. It hits Himalayas and splits into two branches. Okay, it hits Himalayas and splits into two branches. Okay, northern branch above Himalayas and southern branch below Himalayas.